Welcome to today's Explainer. I'm really thrilled you're here, but we need to jump right in because the clock is already ticking. Today, we're literally tearing down the walls to look at the hidden science of property restoration. When disaster strikes, it just feels like total chaos, right? But behind the scenes, saving a structure is this incredibly precise, scientific operation. We're going to look specifically at the data and the exact methodology used in Petersburg, Virginia. It's a place where geography and history kind of combine to create some really unique challenges. From the very first drop of water, this massive biological and physical countdown begins. So let's get right into it.
All right, picture this. A pipe bursts. Water is just rushing across your floor. What is your absolute first move? Because every single second that ticks by is literally altering the structural integrity of your property. This isn't just some mess you can casually mop up. This is an active, escalating biological emergency, and you, my friend, are immediately on the clock.
The source material lays down a really harsh reality here. It says every hour water sits in your property increases damage and restoration costs. I really want you to hear that. Every single hour. Water damage is absolutely not a passive event that just sort of happens to your building and then stops. No, it is a highly aggressive, rapid onset disaster. It's actively destroying your property minute by minute. The longer you wait, well, the more of your building literally has to be demolished.
So the crucial point is 90 minutes. Our source material points out that starting mitigation within 90 minutes of your call is the critical emergency response window. If professional truck-mounted extraction and stabilization begin within this specific hour-and-a-half window, you can actually prevent the kind of catastrophic secondary damage that just doubles restoration costs. In this game, speed is literally your most valuable asset.
Section 1. Petersburg's vulnerability and local threats.
Okay, let's dive into this. Localized knowledge is absolutely critical in restoration. Think about Petersburg. It sits right on the Appomattox River, which immediately creates major flood risks. But it's also built on these Virginia coastal plain soils, which are incredibly heavy in clay. So during a heavy rain, that clay doesn't drain at all. It basically just channels all that water straight into basements. Add to that the really aging, unwaterproofed historic homes in Old Town and Walnut Hill with their corroding cast iron pipes, plus the flat commercial roofs out near the Fort Lee corridor that suffer from serious water ponding issues. You can see why this region is just a prime target for sudden water emergencies from multiple angles.
Section 2. The contamination countdown and water categories.
Now, what's really interesting about this information is how the IICR CES 500 standard strictly classifies water. It basically turns what you might think is just a standard plumbing headache into a high-stakes biological assessment. So Category 1 is your clean water, like from a burst supply line. Category 2, which they call gray water, comes from things like a washing machine overflow and has moderate contaminants. But then you have Category 3, black water. This is sewage or floodwater, and it contains highly pathogenic agents. The crazy thing is, this category dictates exactly what materials can be saved and what absolutely must be destroyed.
But here is the genuinely terrifying reality. That clean, Category 1 water from your burst sink pipe, it instantly degrades to Category 2 or 3 the very moment it touches your floors, your drywall, or your insulation, because it picks up dirt, chemicals, and bacteria as it travels through the structure. So completely safe water becomes highly hazardous in an instant. This changes the entire restoration protocol and drastically increases the health risks to literally anyone inside the building.
Section 3. The 48-hour mold window and the environmental reality.
48 hours. In Virginia's highly humid climate, 48 hours is exactly how long it takes for mold to visibly colonize in wet materials. Once you hit that 48-hour mark, you aren't just dealing with a water problem anymore. You're dealing with a toxic mold infestation, and that requires severe containment, HEPA air scrubbing, and usually some pretty major demolition.
And this brilliantly illustrates the massive, incredibly costly difference between trying to handle this yourself versus calling in the professionals. Just think about DIY drying for a second. You throw down some towels, you run a few box fans, and you just kind of hope for the best, right? But what actually happens? Well, hidden moisture wicks right up into your wall cavities, leading to structural rot and that rapid mold growth we just talked about. Now compare that to professional mitigation. They use thermal imaging and targeted dehumidification. This scientific approach actually saves your original structures and flooring instead of forcing you to rip them all out and replace them.
Section 4. The physics of drying. Going way beyond just running fans.
Have you ever heard the term psychrometrics? It's basically the scientific relationship between temperature, ambient humidity, and material moisture content. Proper restoration is a strict exercise in physics, not guesswork. Technicians actually have to calculate exactly how many dehumidifiers and air movers are needed to pull moisture out of really dense materials, like hardwood and concrete. And they have to do this while simultaneously removing that moisture from the ambient air so it doesn't just settle right back down. It's a crazy environmental balancing act.
To execute this giant physics experiment, you need some serious hardware. We are definitely not talking about a basic wet vac from the local hardware store. Technicians use massive, truck-mounted extraction vacuums that can pull hundreds of gallons of water per hour straight out of carpets and subflooring. They pair these with thermal imaging cameras to literally see the water hidden behind your drywall. Plus, penetrating moisture meters to track the drying progress in real time, HEPA-filtered air scrubbers, and EPA-registered antimicrobials to make absolutely sure the environment is biologically safe.
Let's see how this all builds into a strict, structured procedure. Step 1 is the immediate assessment and IICRC classification, so figuring out exactly what category of water we're actually fighting. Step 2 is rapid truck-mounted extraction to stop that wicking process dead in its tracks. Step 3 is the controlled structural drying based on those complex psychrometric calculations. And finally, Step 4 is the physical restoration and the final walkthrough to ensure the property is fully returned to its pre-loss condition. That's 4 distinct, incredibly precise steps to save a structure from total ruin.
Section 5. Navigating insurance claims and the bureaucracy.
If you ever have a major property loss, you absolutely need to know this word, Xactimate. Direct insurance billing is entirely driven by Xactimate software. It is absolutely critical that the restoration company uses this specific software because it provides the exact standardized pricing model and the language that insurance adjusters natively recognize and accept without an argument. Honestly, if your restorer isn't using it, you're going to face some massive delays in getting your financial recovery.
But the software is really only as good as the data put into it. You need crucial claim documentation. We're talking initial baseline moisture readings, daily drawing progress logs, thermal imaging proof showing the hidden water, photographic evidence of the equipment in action, and justified S500 scoping narratives. Look, successful restoration is essentially a rigorous data-gathering mission. Without this strict daily collection of scientific proof, property owners will end up fighting adjusters over every single dollar. It's the data that forces the approval.
Wow, okay. We've covered the hidden science, the biological threats, the physics of drying, and the heavy bureaucracy. So I want to leave you with this final provocative thought. If a pipe bursts and that critical 90-minute clock started right now, is your property prepared? Do you know your local risks? And do you know exactly who to call to deploy the science needed to save your walls? Keep this explainer in mind the next time the rain starts pouring in Petersburg. Stay curious, stay prepared, and I'll catch you next time.